Imagine this. You're standing in a forest when suddenly the air crackles with electricity. The hairs on your arm stand up. A flash of yellow darts between trees. Before you can react, a small creature leaps into view, cheeks sparkling with raw electrical power.
Who's that Pokémon? It's Uncle Ben. It's Pikachu!
The most famous electric mouse in history. But here's what's keeping me up at night. How does a creature smaller than a house cat generate enough electricity to power a small town? The answer might just rewrite everything we know about biology. Today, we're diving into the shocking truth behind Pikachu's powers, and trust me, it's way more mind-blowing than you think. Let's get electrified. First, let's tackle the obvious question. How much electricity can Pikachu actually produce? According to the Pokédex, Pikachu can discharge electricity powerful enough to paralyze even an Indian elephant. That's not just cute, that's terrifying. An elephant weighs around 5,000 pounds and has thick skin. To paralyze something that size would require at least 10,000 volts. For comparison, your wall outlet is just 120 volts. So Pikachu isn't just giving you a static shock, it's hitting you with the equivalent of a lightning bolt. But here's where it gets weird. Pikachu weighs just 13 pounds and stands knee-high to a human. There's simply no way a creature that small should be able to generate that much power without literally exploding. Unless the secret lies in Pikachu's most distinctive feature, those red cheek pouches. Most people think they're just cute circles on Pikachu's face. Wrong! They're actually biological supercapacitors, nature's version of the most advanced energy storage technology we have. Inside those pouches are millions of specialized cells called electrocytes, stacked in perfect alignment like microscopic batteries. When a single electrocyte fires, it creates about 0.15 volts, barely enough to notice. But when thousands fire together, that's when the magic happens. Think of it like this. One person clapping makes little noise, but a stadium of people clapping in perfect sync, that'll shake the ground. Electric eels use a similar system, but Pikachu takes it to another level entirely. While an electric eel has about 6,000 electrocytes, Pikachu's cheek pouches might contain millions, densely packed in a spiral arrangement for maximum output. But that still doesn't explain the real mystery. Where does all that energy come from in the first place? Here's where we need to think beyond normal biology. Remember Pikachu's diet? It mainly eats berries and other plant matter. There's no way a berry-based diet provides enough energy to generate lightning-level discharges. Unless Pikachu isn't just digesting food, it's harvesting energy at the quantum level. Scientists studying bioquantum mechanics have a wild theory. Pikachu's body might contain structures that tap into zero-point energy, the background energy that exists in empty space itself. Sound like science fiction? It's not. Zero-point energy is real. It's the reason why atoms don't collapse even at absolute zero temperature. There's energy everywhere, even in empty space. What if Pikachu's cellular structure evolved to harvest this omnipresent energy? It would explain how something so small could produce so much power without massive fuel intake. This would make Pikachu not just a cute electric mouse, but potentially the most energy-efficient organism in existence. A living fusion reactor in fuzzy yellow packaging. But generating electricity is only half the mystery. The other half is not frying itself in the process. When you run electricity through something, it heats up. It's why your phone gets warm when charging. Now imagine generating enough electricity to power a house inside your body. You'd be cooked from the inside out. So how does Pikachu survive its own attacks? The answer lies in its iconic yellow fur. Under a microscope, Pikachu's fur isn't just hair, it's a complex network of hollow filaments filled with a silicon-like compound. These filaments act as perfect insulators while also working as miniature heat sinks, dissipating excess heat into the air. This fur system is so efficient that engineers are trying to recreate it for next-generation electronics cooling. Imagine your gaming PC cooled by synthetic Pikachu fur instead of noisy fans. But there's another crucial piece of the puzzle. Pikachu's lightning bolt-shaped tail. That tail isn't just for show, it's a biological grounding rod. When Pikachu generates massive voltage in its cheeks, excess charge flows through specialized conductive tissue to the tail, which then safely discharges into the ground. Without this safety mechanism, Pikachu would essentially be a living bomb, accumulating dangerous levels of charge until, well, let's just say you wouldn't want to be holding it when that happens. The tail's distinctive lightning shape isn't random either. That zigzag pattern maximizes surface area for discharge while minimizing weight. A perfect example of evolution optimizing for function. But this leads us to the biggest mystery of all. How do Pikachu evolve these incredible adaptations in the first place? Evolution typically works in small steps over millions of years. But Pikachu's electrical system is so complex and integrated that it creates what scientists call an evolutionary leap problem. How do you evolve something as complicated as bioelectricity generation when half a system provides zero survival advantage? The answer might lie in Pikachu's evolutionary family tree. Pikachu evolves from Pichu, a baby form that can barely control its electricity. In fact, Pichu often shocks itself by accident. This suggests the electrical system evolved first for something other than attack or defense. The leading theory, communication. Electrosensitivity likely evolved first, allowing ancient Pichu to detect subtle electrical fields from predators or prey. Then came small electrical discharges for communicating with others of its species, like a biological Morse code. Only later did these mild shocks develop into the thunderbolts we see today. It's similar to how birds' feathers evolved first for insulation, only later being repurposed for flight. But there's still one thing that makes no scientific sense: Pikachu's ability to target its electricity. In the wild, electricity follows the path of least resistance. It doesn't aim. Yet Pikachu can somehow direct electrical attacks at specific targets without hitting everything in between. How is this possible? Recent research in quantum biology suggests Pikachu might be manipulating something called quantum tunneling, a phenomenon where particles can pass through barriers that should be impenetrable. By controlling the quantum state of electrons in its cheeks, Pikachu might be able to teleport electrical charge directly to a target, bypassing the normal rules of electrical conductivity. If true, this would make Pikachu not just an electrical powerhouse, but a living quantum computer, processing information in ways our most advanced technology can only dream of. So, what does all this mean for the future? Scientists studying Pikachu's unique biology are already developing technologies that could revolutionize our world. Bio-batteries that could power your phone for weeks on a single charge. Self-cooling electronics inspired by Pikachu's fur. Quantum energy harvesting that could end our dependence on fossil fuels. The implications are staggering. What if we could create medical implants that never need battery replacement? Or electric vehicles that charge themselves as they drive? All from studying a yellow electric mouse. Pikachu isn't just shocking because it's electric. It's shocking because it represents what might be possible when biology and physics merge in ways we're only beginning to understand. If you found this mind-blowing, watch our other videos. And other than that, stay curious and stay electric.